Hello, we are physics dinosaurs, and our proposal is the flight patterns of different flight mechanisms in zero gravity. So our motivation and inspiration. So as humanity advances, we believe that we must adapt our transportation and flight mechanisms to new environments, such as microgravity. And on the International Space Station, for example, there are current drones and robots that are being used, like InBall and Astrobeam, which don't use conventional wing mechanisms or conventional propulsion standards. And we believe that this led us to the question of how whether traditional flight mechanisms would handle inside these kind of zero-G environments. And thus, inside exploring these conventional and traditional wing mechanisms, it allows us to open the door to see the different principles that are at play that causes them to design robots like this. Due to this, this study ultimately aims to contribute to advancing robotic mobility in extraterrestrial environments. Or abstract. So, flight on Earth is governed by aerodynamic forces, which are lift, thrust, and drag. And these forces all rely on Bernoulli's principle, in which that different airflow differences underneath and over the plane wing causes lift. But the lift is on Earth is used to counteract the force of gravity and create the upward mechanism to create the plane to actually stay in air. But on microgravity, that is not needed because it's a zero-G environment. Thus, you wouldn't need to create lift. So in actuality, lift would basically be causing unintended height gain and cause extra height that we don't want. More importantly, because of the stability and trajectory control are also impacted because of the zero-G environment, how it impacts how lift is done. This project investigates the traditional mechanisms like wings and propellers and to see whether they can effectively achieve stability, distance, and accuracy in space. And by exploring these dynamics, we can provide insight for further robotic development inside space.
So this is the procedure for our experiment. Our experiment uses three objects, a bird toy with flapping wings, and a plane toy with wings, and a plane toy without wings. And all of these are powered by rubber bands. And what we'll basically do is turn the rubber band 60 times and let it go and observe the flight path from the side using a camera. And since these experiments are really simple, we're only expecting to take about 2 minutes per trial and about 6 minutes in total. And our hypothesis is based on three criteria. The first one is stability, and the second one is distance, and the third one is accuracy. And for the bird toy with flapping wings, we're expecting it to have significant height gain due to the unwanted lift caused by the flapping of the wings. And for the plane toy with wings, we're expecting it to have stability thanks to the wings, but have a moderate vertical lift. And for the plane toy without wings, we're expecting it to have the most accurate trajectory because of the absence of lift. However, we're expecting it to have rotational instability due to the lack of aerodynamic resistance.
So our theoretical reason, there are two parts. One is the airfoil and lift. So due to the airflow differences inside that airfoil shape, faster speed on top creates a low pressure zone and a slower speed on bottom creates a high pressure zone, creating the lift. The problem is that this lift will be excessive inside a zero-G environment because there is no gravity to actually counteract that lift. More importantly, because of the artificial atmosphere of the ISS, it would generate lift, but that lift is not needed to the zero gravity environment. So thus, a toy with wings would have height gain. But what about a toy without wings? Well, it's based on the stability of wing length. We know that due to the rubber band, it's creating this rotational force that's causing it to go forward by rotating the propeller. The problem is that if we don't have the wing length, it would decrease our rotational radius, thus making the torque making much less torque needed to actually cause the whole system to be spinning. So if there is no wings, what would happen is that the plane without wings would actually start spinning on its roll axis because of the reduced wing length. Because it creates a reduced rotational axis, which would create which will create less torque needed to actually rotate the system. Thus, in case of additional winds, it will be proportional.